Hi, I'm Katrina Riehl. I'm the head of the Streamlit data team at Snowflake. I'm also the president of the board of directors for a nonprofit organization called NumFocus, which supports a lot of open source projects. Today, we're going to talk about open source in the data cloud. So also introducing some of our projects that are associated with the Snowflake community and some of the representatives who are working on them and also using them in order to promote our community and work on making all of this software available. So maybe we could start with some introductions.
Hi, I'm Peter Wang. I'm the CEO and founder of Anaconda, and Anaconda is a software distribution that includes a lot of pre-built packages for machine learning, data science, and numerical analysis. At Anaconda, we've also created a number of open source projects that some of which are part of NumFocus and some of which are incubating and are on their way into joining the NumFocus family of projects. Those include our Dask distributed computing system. That includes Bokeh and Data Shader, HoloViews, some visualization tools and data exploration tools, and even sort of new democratized programming systems like PyScript for doing Python in the browser. I'm really excited to be here.
Hi folks, my name is Willem. I'm a creator of Feast. It's an open source feature store. Essentially, it's a tool you'd use to reliably kind of organize and serve your features to machine learning models. It's a tool we built at my previous employer, Gojek, in Singapore, where we built a large ML platform. And now we're working with a bunch of companies like Shopify and Twitter and Robinhood and others to help folks take analytics data into production for machine learning use cases. So super excited to be here today and chat with you all.
I'm Ryan Blue. I'm the co-founder and CEO of Tabular. We provide a data warehousing storage layer based on Apache Iceberg, which is the project that I started at Netflix while I was there. Iceberg is an open source project that I think a lot of people in the Snowflake community have heard about lately. It provides an alternative storage layer for data warehousing as well as data lake workloads. So if you're thinking about it in terms of Snowflake, it's like take the data storage layer out and make it something that can be shared between Snowflake and other projects like Flink or Spark even, and be able to use everything together as one unified warehouse or data system rather than a data warehouse with sort of well-defined paths in and out.
And as I mentioned, I'm Katrina Riehl. I'm head of the data team over at Streamlit. And Streamlit is a low-code Python, pure Python-based project that provides a quick front end for a lot of machine learning systems as well as data pipelines. And we are actually part of the Snowflake family. So we are going to be providing a lot of Streamlit applications available through the Snowflake product coming up next year. So with that, I'd really love if we could go around and people could tell us a little bit more about the project. What is the technology that's involved in the project? Tell us a little bit more about how it's used and how people, like what kind of users that you're looking for. All right, we're going to go ahead and start with Willem.
Feast is I think it's a project that originally we built to solve problems we had internally at the company, Gojek, where it's basically a ride-hailing company with a bunch of different products and different data sources. So we had this disorganized mess of data within the company and folks producing data and then others on the other side wanting to consume data. And so Feast was really this layer that we introduced between the producers and the consumers. Specifically for machine learning use cases. So it allowed us to organize all of these data sources and then provide a consistent way for models to access that data and without knowing exactly where the data came from. So for example, you can have data coming from streams, data coming from batch sources, data being computed on the fly. As a model, all you want to see as a machine learning model, all you want is reliable access to that data. So for training, you want it at scale from the offline world, and in the online world, you wanted low latency. You don't care if it's coming from an API or whether it's coming from, some person uploading a CSV. And so Feast was really about organizing the data, providing that interface to our users, and then providing these endpoints that these models can interface with. And so that solved a lot of problems for us. And of course, I'm only talking about like the tip of the iceberg here, but there's a bunch of things, a bunch of guarantees that Feast makes And those guarantees, in providing reliable access to feature data or these data points to models is really where the value lies. And so we work a lot with teams that like ML platform teams or ML solution teams, like if they're doing recommendation systems, if you're building fraud detection systems, credit scoring, a bunch of these, those kinds of folks. Specifically in the real-time side is where we see the most value. So if you're just doing batch, you can often just stay in the notebook or with SQL. But when you have to cross the barrier into real-time, these kind of high-value use cases, that's where a feature store really shines because it gives you the organization as well as the reliable data access.
Fantastic. And Ryan, can you tell us a little bit more about your project?
Yeah, absolutely. Iceberg actually comes from the data lake world rather than the data warehouse space where Snowflake is. The data lake world just grew up a bit differently. Tables, basically everything was NoSQL for a really long time. And we threw out a whole bunch of database concepts just to, build distributed systems. And that was incredibly useful, but we lost a lot in the process. So Iceberg was a project to basically clean up tables. And rather than having a very simple and in the end broken abstraction on top of files and directories, we actually built real SQL tables and metadata for use in the data lake space. That solved challenges like ACID transactions, safe and reliable schema evolution, and other things that we all take for granted in the data warehousing space because it's all, a real grown-up SQL database. So that was a really big thing in the data lake space. The interesting thing is that in solving sort of atomic transactions across various compute engines that knew nothing about one another, we ended up solving the problem of concurrency and how to tie together engines that are very good at different things. And that's really why the data warehouse engines like Snowflake are growing in interest and support for projects, or just for Iceberg, I guess. Is because now you can separate storage from Snowflake and share that storage layer with all those other engines and frameworks. And that's really exciting. There are still some definite challenges like security and, how do you actually run a system like this? Because again, in the data lake space, it's a lot of like open source projects and go build your own thing. But it's really exciting to be able to just share the data and operate directly rather than making copies and or just going with lake storage without any of those SQL-like guarantees.
Excellent. And maybe Peter, you can tell us a little bit about the Anaconda distribution, maybe some of the projects that you all are incubating.
Yeah, so the Anaconda distribution itself is like I said before, a collection of pre-built packages for doing Python or R. Actually, I have several languages of packages in there. But the idea is that some of the fundamental tools that people use for doing data analysis and machine learning, these actually have very, very complex and very nuanced build steps. So it's not maybe the sexiest thing in the world, but it's really important to get it right, because doing it wrong can be, sometimes incur a order of magnitude difference in performance, or at other times things just break in production randomly because some build flag wasn't turned on when some other package was built. So we just try to take care of a lot of that for people. And then we also, of course, provide open source tools like Anaconda Build. So a larger open source community around Anaconda called Conda Forge, they go maintain recipes and build packages for an even larger set of packages than we can build ourselves. But one of the values of what Anaconda provides is not only sort of a kitchen sink installer that includes a lot of the basic packages you might need to get started with data science, or to teach a course, let's say, to a room of 150 people with very different laptops. But also in partnering with Snowflake, we're able to provide a hardened and well-conditioned set of packages for use in environments like Snowpark, so that people can now be doing Python on well-known, not randomly download off the internet software, but actually vendor supported software inside inside their Snowflake database. So that's kind of Anaconda and Conda, kind of that side of things. But we also do work on a number of different open source projects that we hope to move the ecosystem forward. And so I think actually related to, sort of inspired by what Willem and Ryan talked about, a couple of projects that we've built are somewhat in a related vein. So we have a project called Intake, which is meant to be a virtual data mapping for array data for regular sort of scientific numerical data, but over a variety of different locations, whether it be files, whether it be cloud buckets or whatever it is. So I think a little bit similar to what Iceberg providing a SQL layer over whatever kind of NoSQL data lake thing you've got. Intake is an attempt to do that with things like NumPy and Pandas, right? Providing a way to get remote access to not chunked, but regularized data, not just data table kind of data. So it's gotten very heavy use and traction in the scientific computing community and the climate science community, where they have hundreds of petabytes of data stored in the cloud, and they want to just do simple array things or simple numerical scientific things. And that's really hard. We have scientists trying to apply Fortran to 100 petabytes in the cloud, right? So Intake bridges that. And then in a kind of a thing kind of related to the Feast side of things, we incubated a project called Dask, which is a distributed and delayed computing system for Python that provides an API like NumPy or Pandas, but it actually builds a compute graph, and then it maps that onto data, and it could also partition that and map it onto a lot of workers in a distributed kind of environment. And this might not seem like it has a lot in common with a feature store, but our vision for that project was to allow on-demand computation and build essentially almost like materialized views, right? But for numerical and scientific and of course data framey sort of things over wherever your data sits. So when you look at Intake, you look at Dask together, these two projects try to provide for the NumPy and Pandas layer of the ecosystem some of the same things that a feature store does for those ML use cases, right? In a kind of an on-demand need, and then also what Iceberg provides in terms of providing a SQL style interface over a wide variety of data sources.
Fantastic. And by the way, I can remember the days when we used to spend an entire day installing all of those packages like NumPy and SciPy and everything in order to get going on the Python scientific ecosystem. It was definitely quite a painful experience. Speaking of painful experiences, though, I do want to talk a little bit about the Streamlit project. When I joined Streamlit, I was actually a huge fan and user of Streamlit because of the low-code Python interface. So what it allowed you to do was suddenly you were in a position where you could create very interactive web UIs on top of machine learning models, which was primarily what I was using it for, where people could interact with their data, they could interact with the models, they could interact with results without having a data scientist involved, first off, but then also allowed that interactivity that made them understand the models better, as well as be able to apply them to decision making faster. And so, for example, if we were to deploy a machine learning model, and then we actually built it into our entire build system so you can deploy a Streamlit app along with it. Suddenly you were in the position where like your finance organization or your infrastructure organization or whoever was suddenly able to interact with that model automatically. They did not need to have any sort of intermediary. They didn't have to query their database. They were able to actually use that. But also by being a pure Python package, suddenly it opened up that entire Python scientific stack as well that Peter was talking about. So if you're using Pandas under the hood, you're using NumPy under the hood, you're using any of the other projects, even Altair and Bouquet and things like that, it has the potential to integrate with all of these very, very easily and provide some glue for everything involved here. By the way, speaking of which, using Feast as our feature store on the back end, we were able to, incorporate that into the entire ML pipeline and put that, up in front. Obviously, as the director of data science, this was a huge win for our organization, where suddenly we were able to do all of this work without a ton of code, where it used to take us months in order to put together UIs that were meaningful on the web. Suddenly we had them available within days. And so that was just an enormous productivity saver, as well as just having that interactivity, making people actually work with the data themselves and become more data literate themselves, and provide that self-serve machine learning and analytics that a lot of people are looking for. So definitely a huge win on that part. I also just want to mention, moving on, we talk a lot about, creating these open source packages. And I kind of want to dig into a little bit more, why open source? Why were these packages, put out into the open source community? What was the value there? And how do we look at that as, a service, or as how do we relate to the community? So somebody want to jump in and kind of talk a little bit about the thinking behind that?
I'd be happy to go there. I think we have a fairly unique story as a data layer. We knew from the beginning that, data formats are forever. And what we needed as a community, and this was when we were at Netflix and we were working with companies like Apple and LinkedIn and Pinterest and Airbnb. And, we all had basically the same infrastructure and we were struggling. We knew that what we wanted was something that we could all share, where we could collaborate on the project and really make something larger and better than we could on our own. And we also really wanted the existing projects to pick it up and work with it and, be compatible, even if they were closed source or, like a Redshift or an Athena or something like that. So we knew that we had to build something that was not only open, where we could all collaborate on it, but actually like neutral and something that would be trusted by closed source engines to, integrate. We wanted to be able to use engines like Snowflake that are awesome, but you have to work pretty hard to make it so that Snowflake or other companies are confident that their invested dollars in R&D into this format are not going to be wasted when someone changes it to try and be better than them later on. And so that's one reason why we went to the ASF and made sure that the community itself is run as a very opening and welcome place where everyone, even if you're from vendors that compete, is able to contribute and be part of the project.
Absolutely. So just jumping in, putting on my NumFocus hat for just a second, I do want to mention the fact that we tell people this all the time, that working on open source projects, you do get access to that group of developers, right? You have the cut in R&D costs that it takes, to have a successful project. Having kind of a mind share that comes from different perspectives in order to make a project better, I think is a huge benefit in order to, for releasing things in the open source community.
So basically, one of the key things was just generalizing the project and making it more adaptable to different use cases. And so we de-risked a lot of the product risks with ML tooling by open sourcing the feature store and ultimately moving it into the Linux Foundation in order to make it neutral, give companies confidence that they could adopt this and use it at scale. And if my team or any other team goes away, they can continue to contribute and fork it or do whatever they want with it, wrap it. Yeah,
a lot of open source seems to come from that when practitioners start talking to each other and they realize, hey, we're all trying to solve the same problem and we've all got our own kind of crummy version of this, like half-baked version of solving this problem. If we put all of our brains together, we would have more than enough to actually move something forward. And I think about the fact that the origins of the pandas library came in a time when there was, like, essentially in the Python community, there were like 6 or 7 different labeled NumPy with records sort of masquerading as tables kinds of things. And then there was a bake-off a little bit, and then Wes McKinney, the creator of Pandas, sort of just coded harder and spent like 2 years coding for 100 hours a week kind of thing, and writing a book about it and everything. And it sort of took off and won in that case. And that's the kind of the evolution of a lot of the open source. It's like, I see it as a Shelling point. And to your point, Willem, about de-risking the product market risk thing, the reason why open source innovation is so amazing is because it comes from the actual, it's almost like born ready. It's born having that at least technology market fit, if not product market fit, right? Because it comes from the practitioners themselves, usually, right? When it's grassroots open source, and not astroturfed open source, right? And so we've seen, of course, a lot of that in our in our Python community. Ironically, however, Anaconda itself was not that. So the company Anaconda, I don't know how many people know this, but Anaconda started as a company called Continuum Analytics. And we were hoping to build a lot of these different things that we saw people needing, things like Intake and Bouquet, the visualization system, and Dask. We're hoping to build a lot of these kinds of open source software. But we realized very quickly that people couldn't even install 10-year-old software like SciPy and Matplotlib. And so we sort of took a detour to go and build this like package system installer thing. And then that became so wildly successful that we sort of like, hey, all right, everyone knows this is this now. So it's almost the inverse. It was like solving the problem that nobody wanted to solve and everyone was struggling from. And so we kind of, that's how Anaconda itself came about. But that wasn't the point of why Travis and I started the company. We started the company to try to, help Python get to the next level of adoption in business and make Python suitable for business data analysis. So yeah, that's kind of the origins of some of the things that we built. But really, the vision for what we wanted to do and all of that was around democratization, was around getting more people, more practitioners or subject matter experts or domain experts, getting more of the people who would not normally consider themselves as software developers, getting them to be able to use a little bit of code in Python, maybe write in a notebook, maybe write a script, but they are then able to have the most powerful tools at their fingertips. They don't have to think about data topology. They don't have to think about infrastructure. They can just write some code and they're able to, it's sort of like the idea from the supercomputing world of moving code to data, right? But the idea here is to move code and context, right? Move the better questions in the person's brain, moving that to data. And that was the push behind everything we did. And it continues to this day to projects like PyScript, where we want to open up web programming and people being able to deploy applications in the browser, in a similar spirit to what you're describing, Katrina, with Streamlit, right? The massive empowerment you see in organizations when end users can build applications, they can access data wherever it is, whether it's streaming, whether it's batch. They can then create transformations of that data, store it somewhere for other people to go and party on, and without having to go through this giant long loop of going to a data engineer and data management and all this stuff. That ability to give everyone when everyone has the ability to build those kinds of applications, to ask those questions, to put their views on data kind of in a place that can be shared by other people, that really unlocks so much productivity inside businesses. And that's a driving vision for almost all the open source that we do at Anaconda.
Awesome. I also just kind of want to, touch on something that you talked in here is the relationship of community, right? We have different kinds of community. So we have our developer community, we have our user community, and they interact with each other. And ultimately, we would really love to have, overlap between those. But there's also the reality of the fact that we're trying to develop either libraries or programmatic tools, things like that need to be developed within this one context. But then we also have the users that are developing with them and have to be able to use the tools and that we want to adopt them. So can maybe talking a little bit about like, what does that relationship look like and how is that balanced within your different projects? I can go ahead and go first just a little bit because we do actually have a distinction, right? Where we have the people that are in our core developer team basically on Streamlit. They are the ones who are doing, integration with other visualization projects. They're the ones that are bringing in things like Altair or Bouquet, things like that, the integrations. They're the ones that are adding new features. They also have another team that works on our community cloud, which we do have available in order for people to be able to try out Streamlit, deploy Streamlit apps themselves in a limited way, be able to share knowledge in that way. But then we also have, our actual Streamlit community, right? That is coming in, and we have users that can give us feedback that are, very active in the forums, that are very active in giving us that feedback of what is necessary in order for them to do their work stream. But at the same time, we do have this very separate area where the developers in some way, are very much tied to their roadmap and their timelines and all of the things that are working there, more from like a, very traditional, software team perspective. But we also have these users that are out there creating amazing things that we want to have people, that are available and out there. But not all projects work that way, right? And so I kind of just want to throw that out there, how other people are handling that.
For us, the user community is just now being built. We've for a long, like, Iceberg is a fairly low level infrastructure project. It's the tables that get built into the processing engines that real people actually use. So for a long time, our community has been primarily developers and people on data platform teams. The people that take all these open source projects like Spark and Trino and Flink and provide a platform to other people, the data engineers in their companies. We wanted to expand beyond that community, and that's actually why we started Tabular as a company. It's because we knew that the level of expertise necessary to say, oh, I want these 10 different open source projects, I know how to configure them and get them working together and deliver a platform for other people, is just not the way most companies go, right? How do you find that person? And so as Tabular, it's our job to provide the basis of that platform, the Iceberg layer, the security, as well as just make it easy for people to plug in stuff like Snowflake. We want people to immediately be successful. And so we're building out that user community and sort of, generally available data platform at the same time. But that's a very new thing for us because, again, we've primarily had this developer community of very deep, technical people. And we're trying to widen that to all of the users that are out there and build that user community.
And I hate to jump in right now. It's been such a fascinating conversation, but maybe real quick, we can go around and people can talk about how people can get involved in their projects before we wrap up.
So with Anaconda, there's many different ways to get involved. We have a wide variety of different projects. If you go to anaconda.com and you go and look at our open source projects, there's a number of things there, from visualization to even a compiler if you're interested in working on compilers. And on the package building side, the Conda Forge community is wonderful. And if there are software tools and packages that you'd like to see available and built, better, then that's something you can join. But then also our very nascent project, PyScript. If you go to pyscript.net, you can learn more about what that's about. It is really in day 0.1 right now of that project. So it's a great time to get involved. And I think it'll be really transformative for how people do write web applications and WebAssembly using WebAssembly. So I encourage people to go to any of those sites or look at those different things if they're interested in working with us on these things.
Absolutely. And just real quick, also talking about Streamlit is available through streamlit.io, but also it's available on the Anaconda channel as well. So you can get it there, as well as also you can just pip install it as well. It's available to everyone.
Yeah. So to get involved with Feast, you just need to go to feast.dev. We've also got a massive Slack community at slack.feast.dev. So bring a use case and get involved, and we take it from there.
And for Iceberg, the best way to get involved, I think, is to join our Slack community. Talk to other people there, share what's working for you, learn and ask questions. Really be part of that user community, interacting with other people also using Iceberg. If you want to get involved in development, we mostly work on GitHub, open issues and PRs. We love seeing new people. Please, we're really happy to have new people come and ask what they can do to help out.
Fantastic. Well, I just want to thank everyone for being on our panel today. Very, very grateful that you took the time in order to tell us more about your open source projects and how they relate to the community and to Snowflake. Thank you so much for your attention.
Snowball fight! Wow! You really stepped up your game! I've been using Snowpark, silly! It lets you build snowballs with confidence by removing data security and compliance barriers to production with consistent, enterprise-grade governance controls. Pretty cool, right?
Wait, what?
Frosty gets his own song. Why aren't we singing about Snowpark? The easy way to production for Python! Using pre-installed packages and automated dependency management and secure processing. How do we make that rhyme? Oh yeah, speed! Woo! I built this myself. Nothing could go wrong. Oh no! Ah!
You didn't use Snowflake Snow Park. It's the only way to go. Woohoo! I'm going so much further. Eat my snow!